Hello everyone, this is Rotaract Silva and welcome to the fourth session of Road to A Plus project done by the Rotaract Club of NSBM. So today it's going to be a very interesting lesson because we are going to start off the first lesson related to chemistry. Okay, so in the last few days, in the last few sessions, we did lessons related to biology, whereas today we are going to do a chemistry lesson. Let's screen share and then start off. Nature and properties of matter. Let me start by asking you this question. What do you mean by chemistry? Because this is a chemistry lesson. Chemistry is, children, the branch of science which is related to, the study of learning about the composition of matter, the reactions, the chemical reactions. So everything which relates to matter and reactions, those are included in chemistry. That is the branch of science. Okay. So today we are going to learn about the nature and properties of matter. What is matter, children? What is matter? Matter is something which occupies space and also has a mass. There are two main characteristics of matter. It occupies space and it has a mass. Okay. So matter is mainly divided into pure substances and non-pure substances. Matter කියන එක pure substances and non-pure substances කියලා දෙකකට බෙදෙනවා. Non-pure substances is they are also known as mixtures. Okay. So what are pure substances, children? Matter that contain only one constituent with specific properties are called pure substances. Pure කියන්නේ මොකක්ද? You can take it from the word itself. Pure is පිරිසිදුනේ. හරිද? එතකොට එක constituent එකක් විතරක් තියෙන with just specific properties, you call that matter as pure substances. The matter which has only one constituent and just some of the specific properties, then you call them as pure substances. So there are some examples given to you all. Aluminium, silver, copper, distilled water, carbon, sulfur, zinc, copper sulfate, sodium chloride. These are all pure substances. Okay. Whereas when there are two or more constituents, then you call it as a mixture or else non-pure substances. අපි තමු හිතන්නකෝ කිරි වීදුරුවක් තියෙනවා. There is a glass of milk. Okay. And just imagine it's a glass of water, then it will be easy because water is colorless as well. So you can see when something is being added. No, let's say there is a glass of water. Okay. And then a drop of paint or something, it's been mixed with water. Now what do you call it? Is it a pure glass of water? No, because paint is being mixed. මොනාහරි නිකන් හිතන්නකෝ paint පොඩි චුට්ටක් විතර හැලෙනවා. මොනාහරි කරන්න ගිහිල්ලා හැලෙනවා. කියලා හිතන්න. එතකොට දැන් මේ වතුර වීදුරුව pure වතුර වීදුරුවද නැහැ. ඒ වතුර pureද නැහැ. ඇයි paint හැලිච්ච හින්දා. ඒ වගේම තමයි. Okay, now that glass of water is like a mixture. It's a non-pure substance. Okay. So likewise, children, when there are two or more constituents, then you call it as a mixture. So air, drinking water, salt solution, you call them as mixtures. Because if you take air, is it just oxygen that's in the composition of the atmosphere? No, there's nitrogen, oxygen, carbon dioxide. There's many more. Okay. So it's a mixture, a non-pure substance. Okay. And then you have learned this in grade 8 that pure substances can be also divided into elements and compounds. These pure substances can be divided into elements and compounds. Now, how does this classification is been done? Matter is here. Matter has a very simple definition. If there's something which occupies space and has a mass, then it's a matter. And matter is being divided into pure substances and non-pure substances. Pure substances are further being classified into elements and compounds. So what are elements, children? If there is a substance with specific properties and they cannot be further divided by either physical or chemical methods into substances with different properties, then you call them as elements. ඒ කියන්නේ ළමයි දැන් හිතන්නකෝ pure substances වගේක් තියෙනවා and there are specific properties. ඒවා අයමත් බෙදන්න බෑ, ඒවා divide කරලා කඩන්න බෑ, so that the outcome has different properties. දැන් අපි තුමුකෝ අපිම හකුරු කෑල්ලක් තියෙනවා කියලා. ඔබ කඩුවම මෙහෙම අපි තුන් කඩලා දානවා කියලා හකුරුමනේ ඉතුරු වෙන්නේ. හරිද? එතකොට දැන් මෙතන තියෙන එක නෙමෙයි. different properties වෙන විදිහට මේවා කඩන්න බෑ. කියන්නේ elements කියන එක elements you cannot further divide, like you can't further break it into pieces, not actually break but further divide. Okay, by physical means and also by chemical means. You cannot use both the methods. Okay, and then the outcome won't be something with different properties, and that you call as elements. මොන හරි දෙයක් තියෙනවා pure substance එකක් specific properties එක and ඒවා further divide කරන්න බැරි නම් physically වත් chemical methods එකක් use කරලා so that the resulting substances has different properties. එහෙම කරන්න බැරි නම් then you call it as elements. So what are some elements given in the book? Iron, sulfur, chlorine, zinc and copper. So we'll be learning about the main elements. Okay, so up to now 120 elements are being discovered, but don't worry, you all don't have to learn these 120 elements. You have just 20 elements. But then keep in mind there are 120 elements discovered up to now, because children, science is something which is evolving. The science, the lessons maybe, okay, I can't be so sure with the fact I'm saying right now. The science, the lessons, some facts I learned when I was schooling, when I was in grade 9, might be a bit not changed fully, but new points might have been added, some points might have been withdrawn, some small things might be amended or changed when it's in this year, because science is something evolving with the advancement of technology and with the rising of really good machines and stuff like that. New things can be discovered. So yeah, science is something evolving. Okay, so these 120 elements, you can't be so sure that the next year children who will be sitting for the grade 9 examination will also get this, because ඒ වෙනකොට තව element එකක් හොයාගෙන තියෙන්න පුළුවන්. හරිද? හැබැයි දැන් වෙනකොට elements කීයක් තියෙනවද? 120. මේකෙන් 20යි ඔයාලට පාඩම් කරන්න තියෙනවා. Okay, so now these are some elements. What are compounds? Compounds are also pure substances with specific properties. That the first sentence won't change, because somehow elements and compounds both comes under pure substances. So the first line won't change. Pure substances with specific properties. Okay, formed by the chemical combination of two or more elements in a fixed ratio. ඒ කියන්නේ දැන් අර elements කියන එක දන්නවනේ. elements දෙකක් හෝ ඊට වැඩි ප්‍රමාණයක් එකතු වෙලා, ඒ කියන්නේ එක මොකක් හරි ratio එකකට, fixed ratio එකකට එකතු වෙලා හැදෙනවා නම් ඒක compound එකක්. Okay, the definition is really easy, children, if you understand it. So compounds are pure substances with specific properties, and they are being made by the chemical combination. මෙහෙම දෙකක් මෙහෙම දැන් මෙහෙම එකතු කරනවා නෙවෙයි නිකන් physical means වලින්, but chemical combination. chemically දෙකක් හෝ ඊට වැඩි ප්‍රමාණයක් elements, if you combine them in a fixed ratio, then you call it as a compound. Okay, so if you take glucose, what's the chemical formula? C6H12O6. Now there are C6H12O6 means, children, there are 3 types of different elements. You have the carbon atom here, there, you have the hydrogen atom, you have the oxygen atom. C6H12O6. Okay, C6H12O6. So there are 3 types of elements, which means that it is a compound. Copper sulfate. What is the chemical formula of copper sulfate? CuSO4. So you have a copper atom there, you have a sulfur atom there, you have oxygen atoms there. Copper sulfate. And that is why we can call copper sulfate as a compound. And we have sodium chloride here as well. What is the chemical formula for sodium chloride? It's NaCl. You have the sodium atom, which is Na, and you have the chlorine atom, which is Cl. So there are 2 elements, the sodium element and the chlorine element. Both together, you have this sodium chloride element. I hope it's clear here. And there is a fixed ratio as well. Now, if you take NaCl, 1:1 ratio. You have this 1:1 ratio. If you take glucose, C6H12O6, you have a 6:12:6 ratio, which means when you simplify it, 1:2:1 ratio. If you take copper sulfate, you also get a fixed ratio like that. Okay. So yeah, that is what you call as a compound. elements ne. එතකොට elements දෙකක් ඒ කලින් ගණන් elements දෙකක් හෝ ඊට වඩා වැඩි ප්‍රමාණයක් එකතු වෙලා fixed ratio එකට හැදෙනවා නම් එකක්, you call it as a compound. Okay, so in detail, first this week we'll learn about the elements. So children, y'all have names. So my name is Senorit. Likewise, y'all also have names. But we of course don't have symbols. What's unique with elements is that they have symbols. So that it's easy to write chemical formulas, it's easy to communicate, it's easy to keep records of them. So they have elements, and these elements are standardized elements where all the countries in the world use these symbols. Just because you think carbon, I don't think the letter C goes with carbon. කියලා ඔයාට carbon කියන එකේ symbol එක මාරු කරන්න බෑ. Because it's standardized and it's been used all over the world. Okay, these are internationally accepted symbols. Very often, English name of the element is used as the base for these symbols. So most of the time, the English name is used. Okay, so if you take carbon, C, the first letter of carbon. If you take oxygen, the first letter of oxygen, O is being used. If you take sulfur, the first letter of sulfur is S, so the symbol you use is also S. Okay, so you have a single letter. If you take these 3 examples, then you have some more as well. You use a single letter, and it has to be a capital letter as well. You can't write oxygen by using the simple O letter. You have to write the capital O letter. Okay. So now here, children, we have used the English words and the first letter of those English words as their symbol. But it's not the same with all the other elements as well. Sometimes the next letter or another letter in the name is also being used. Now imagine carbon, chlorine, calcium both starts with C. So if we go with this first rule over here, then all those 3 elements will have to have the same symbol, which is capital C, which will make things even more hard. Okay, so you can't, it will be really complicated. Okay, so you have to have 3 different symbols for these 3 different elements. So then carbon got its first letter as its symbol, whereas chlorine got Cl and calcium got Ca. So if you read the description, you will understand it. When the names of several elements commence in the same letter, the next letter or another letter in the name is added to the symbol. So chlorine, the first and the third letter is being used. Calcium, first and the second letter. Magnesium, first and the third letter. Aluminium, first and the second letter is being used. But always remember the first letter is always capital. Okay? And then sometimes children, these English names also have its relevant Latin name as well. So sometimes these elements, the symbol that is being used is being derived from the Latin name. Okay, so if you take sodium, the Latin name of sodium is natrium. So the symbol we use is Na. Na is the first two letters of the Latin name of sodium. So copper, Cu, lead, gold, mercury, iron, silver, all these elements, the symbols which have been derived, the symbols are being derived from its relevant Latin name. Okay, but you all don't have to remember the Latin name, children. Not at this stage, and you don't have to. Okay, you don't have to keep in mind these Latin names. In case if you get a MCQ, what is the Latin name of gold? You have to know the symbol. So you know, okay, gold symbol is AU, and then you have these four as the MCQ options. You can easily underline this. Why? Because you know the symbol, and gold is derived from its relevant Latin name. Okay, you all don't have to remember the Latin name, but you all have to remember the first 20 elements in the periodic table. So these are some of the main symbols and the elements you all have to keep in mind: hydrogen, carbon, oxygen, nitrogen, sulfur, chlorine, aluminium, magnesium. You have zinc, silicon, phosphorus, argon, calcium, and iodine. Okay. These are not the first 20 elements. We'll be talking about those elements as well. So let's see what are the elements you all have to keep in mind. The first 20 elements. Building units of elements. You have learned that matter is composed of particles. These particles cannot be observed by the naked eye or even by the powerful microscopes. These small particles are known as atoms. Atoms කියන්නේ ළමයි අපේ normal ලහටවත් naked eye එකටවත් powerful microscope එකකටවත් දකින්න බැරි දෙයක්. These are really small particles. And John Dalton was the first scientist to use the term atom for the smallest indivisible particle from which the matter is made. The English name atom for this particle has originated from the Greek word atomos, meaning cannot be divided further. So children, who gave these small particles which are also indivisible the name atom? John Dalton. Underline it because you all will have to write it, or it might appear in a MCQ paper. Okay, so John Dalton gave the term atom, and this word atom was being derived from the Greek word atomos. Okay, and atomos means, children, cannot be divided further because atoms are the smallest indivisible parts, and matter is also composed by atoms. Okay. Now we are going to talk about the differences of elements and molecules. If you take elements, children, elements are being composed by the same type of atoms. They are being composed by the same types of atoms. එක වගේ atoms ජාතියක් එකතු වුණාම තමයි element එකක් හැදෙන්නේ. The atoms which form different elements are different to each other. ඒ කියන්නේ ළමයි අපි ගත්තොත් iron element එක හැදෙන්නේ iron element කියන්නේ Fe නේ අපි මෙතන ඉගෙන ගත්තේ. Do you all have it? Yeah. Fe කියන එක හැදෙන්නේ iron element එක හැදෙන iron atoms වලින්. එතකොට ඇලුමිනියම් හැදෙන්නේ ඇලුමිනියම් atoms වලින්. තේරෙනවද? So different kind of atoms make different kinds of elements. Okay? And the structures of these different kind of atoms are different from each other as well. So if you take molecules, the units formed by the combination of one or more atoms or the same time or one or more atoms of different types are called molecules. Molecules කියන ළමයි එකම ජාතිය atoms එකතු වීමෙන් හෝ වෙනස් ජාතිය atoms එකතු වීමෙන් හැදෙන එකට තමයි combination එකට තමයි කියන්නේ molecules කියන්නේ. Element is composed of the atoms of the same type. Molecules, one or more atoms of the same type or one or more atoms of different types. So y'all will be able to understand this even better when we are talking about the rest of the parts. Okay. So children, under normal conditions, normally oxygen exists when oxygen molecule එකක් විදිහට. ඒ කියන්නේ O2 විදිහට තියෙන්නේ. දැන් oxygen වල symbol එක O නේ. හැබැයි මේ ඇත්තටම ගත්තම practically ගත්තම මේ oxygen කියන එක exist වෙන්නේ O2 එකක්. O2 විදිහට molecule එකක් විදිහට. There are two oxygen atoms together. Okay. So the smallest form in which oxygen can exist independently is a molecule. The smallest form එක තමයි molecule එකක් කියලා කියන්නේ. මොකද oxygen හැම වෙලාවෙම ඉන්නේ දෙන්නෙක් එකට. අර ඉන්නේ යාළුවත් ඉන්නේ washroom යනවා යාළුවෝ එක්කන් යනවනේ. කන්න යනවා යාළුවෝ එක්කන් යනවනේ. ටීචර් කාට ගියත් යාළුවෝ එක්කන් යනවනේ. ප්‍රින්සිපල් ලාට ගිහුවත් තනියෙන් යන්න බෑ යාළුවෝ එක්කන් යනවනේ. අන්න ඒ වගේ තමයි oxygen atom එක. oxygen atom එකක් තනියෙන් ඉන්නේ. exist වෙන හැම වෙලාවෙම තව oxygen atom එකක්. දෙන්න එකට තමයි මේ O2 molecule එකක් විදිහට තමයි ඉන්නේ. හරිද? ඒ වගේ mainly elements පහක් තියෙනවා. Y'all have to keep them in mind. You'll have to memorize them. O2, N2, Cl2, H2, F2. Y'all can memorize it right now. O2, N2, Cl2, H2, F2. ඒව හැම වෙලාවෙම තනියෙන් ඉන්නේ. O atom එකක් තනියෙන් ඉන්නේ නැහැ. දෙන්නෙක් එකේ. nitrogen උත් එහෙමයි, chlorine උත් එහෙමයි, hydrogen උත් එහෙමයි, fluorine උත් එහෙමයි. හරිද? O2, N2, Cl2, H2, F2. O2, N2, Cl2, H2, F2. Okay? So මේ වගේ දෙන්නේ එකතු වෙලා තමයි ඉන්නේ. Now those elements, children, those molecules actually, they have been formed by the same type of elements. The O2 ඕම දෙකක් නේ. එක જાතියෙම elements දෙකක් එකතු වෙලානේ හැදෙන්නේ. හරි. ඒ කියන්නේ atoms හැදලා දෙන එකම ඒ කියන්නේ formed by atoms of same elements. එකම elements එකේ atoms එකක් තමයි එකතු වෙලා තියෙන්නේ. එතකොට you call them as homoatomic molecules. Homoatomic molecules. Why do you call it as homoatomic molecule? Because it's been made out of the same type of elements. O2, two O atoms. Same in the homoatomic molecule. Yeah. Therefore, elements are composed either from atoms of the same kind or from molecules formed by combining same kind of atoms. That's what we talked about. But they cannot be further divided into simple substances chemically. You can't divide it further into simple substances. Then let's talk about the atomic structure. So this is all about atomic structure. Children, this is not difficult, but y'all have to understand it really well, and y'all should never forget this until you're done with your O levels. And if you want to do science for A levels as well, then don't forget it until you're done with your A levels or with your curriculum, because you will need it. You will need this because this is really, really important. And there are no big or complex, complicated, hard sums here. Are chuti sums here, but you have to use your brain, and it's really easy. Okay, because we are going to learn about the atom, the neutrons, protons, and electrons which are embedded in an atom. Okay. So children, we know matter is made out of atoms. ඒ කියන්නේ matter හැදිලා තියෙන්නේ matter වල building unit එක කියන්නේ matter හැදිලා තියෙන්නේ atoms වලින්. Atoms are the building units of matter කියන්නේ ඒක. And children, the greater part of the atom is an empty space. It is a very unique feature of this atom. ඉතින් atom එකේ වැඩි හරියක්ම empty space එකක් තියෙනවා. ඉතින් අර අපි කියන්නේ සමහරවිට මොලේ තිබුණා නැහැ මොලේ මුකුත් නැහැ කියලා. චූටි knowledge එකක් විතරයි තියෙන කියලා. අන්න ඒ වගේ තමයි. එතන atom එකේ වැඩි හරියක්ම තියෙන empty space එකක්. හරිද? එතකොට almost the entire mass of the atom is concentrated at a central core. මේක මේ මුළු atom එකේම entire mass එක ඒ කියන්නේ central core එක ඇතුළට තමයි ඇවිල්ලා තියෙන්නේ. ගොඩක් වෙලට මැද ඇතුළේ තමයි වැඩි මේ mass එකක් තියෙන්නේ central core. හරිද? මෙතන. So children, this central core is positively charged. Now these things underline and keep in your mind. හරිද? Central core එක මැද positively charged. Positive. And it is called as the nucleus. Mother central core positively charged. Nucleus. That was been discovered by Ernest Rutherford. So you have to memorize the names of the scientists as well. Not everyone, but this Ernest Rutherford and this John Dalton. These people you all have to keep in mind. Okay, Ernest Rutherford and John Dalton. These two are very important in these chemistry lessons. So just remember the names of John Dalton and Ernest Rutherford. Okay, so Ernest Rutherford discovered that the central core of an atom is positively charged, and also children you call it as the nucleus. Okay. Yeah, so then he discovered that the atom has a large empty space and it is positively charged. In the past, the atom was considered a very small particle which cannot be divided further. So until now, right now, until I read this sentence, what did we learn, children? That the atom was very small and it cannot be further divided. But I told y'all, science is evolving. The findings get updated, everything gets evolved, and new things have been, people find new things. So yes, the same thing happened for this concept of atom. People found out, scientists found out that atom was made out of subatomic particles. ඊටත් වඩා පොඩි එකක් තියෙනවා subatomic particles කියලා. තුනක් තියෙනවා subatomic particles: electrons, protons and neutrons. Electrons, protons and neutrons. Okay. Now children, මේ nucleus එක ඇතුලේ තියෙනවා මේ subatomic particles දෙකක්. Nucleus එක ඇතුලේ තියෙන දෙක protons and neutrons. Protons and neutrons are in the nucleus. Electrons, anit subatomic particle, they are very much lighter than these two. අර දෙකටට බරෙන් මාරම අඩුයි. electrons වල බර මාර අඩුයි. ඒවා අර අරක වටේ කැරකි යනවා. Y'all can remember the solar system, right? The sun is there and the planets are going around the orbits. So likewise, it's not the same, but likewise, children, the protons and neutrons are in the nucleus, in the core, the central nucleus, the center, and electrons, they are moving around the nucleus. Nucleus got a character. Okay. Relative to the entire volume of the atom, the volume of the nucleus is extremely small. Yeah, ඒ කියන්නේ අපි මුළු atom එකේම volume එක ගත්තොත් nucleus එකේ volume එක හරිම පොඩි. ඒකනේ අපි කලින් කිව්වේ මේ atom එක හරිම අමුතුයි. මොකද space එක කියන්නේ space එක කියන්නේ වැඩිම තියෙන්නේ ඒ කියන්නේ there's nothing, greater part of the atom is empty space. මුකුත් නැති තැන. Okay, mass එක වැඩිම empty space එක. Okay. So this table, you have to memorize this. Where are the protons? In the nucleus, neutrons in the nucleus, electrons around the nucleus. That I told you. Mass එක අපි හැමදාම you write it relative to the proton. Proton එක එකක් නම්. proton එකේ බර එකක් නම් කියලා හිතලා. එහෙනම් neutron එකේ බරත් එකයි. proton එකේ බර එකක් නම් neutron එකේ බර එකයි. මේ proton එකේ බරට relative වෙන්නේ. එහෙනම් electron කියන්නේ 1 over 1840. So it's really small. If you have 1840 particles, it's just one. Okay, it's really light. And the charge, you put it relative to the electron. Protons are positively charged. So children, it's easy to remember. PP is positively charged proton. Electron negatively charged. Electron negatively charged. Neutron neutral. Neutron neutral. Again, zero. Charge එකක් නැහැ. Then proton එක මොනවාද? plus. Electron එක minus. Neutron එක neutral. ඒ කියන්නේ zero. Charge එකක් නැහැ. So this small table over here, you all have to keep in mind. Okay. Let's go to two very important dimensions. Those are atomic number and the mass number. We use two symbols, children. Atomic number එක අපි denote කරන්නේ Z අකුරෙන්. And mass number you denote it using the letter A, capital A. Okay. Atomic number is, children, the number of protons present in the nucleus. අපි මොකක් හරි element එකක් දීලා මේ element එකේ atomic number එක මොකක්ද කියලා අහුවොත් atomic number එක කියන්නේ ඒ atom එකේ nucleus එකේ තියෙන proton ගාන. දැන් හිතන්නකෝ atom එකක් තියෙනවා. ඒ atom එකේ protons තියෙනවලු 10ක්. එහෙනම් what's the atomic number? 10. Those are similar. Likewise, if they have given you the atomic number, if the atomic number is 7, then how many protons are there? 7 as well. Okay. So it is generally denoted by the symbol Z. And children, there's another one. The atomic number or the number of protons in the nucleus is a unique property of that element. May atomic number and the number of protons is unique to the element. Atomic number can periodic table periodic table 1 atomic number 1 තියෙන hydrogen. ඒක තව කෙනෙක්ට නැහැ. helium ද තියෙනවා helium 2. hydrogen helium lithium 3. දැන් oxygen 8. 8 එකට තව එකක් නැහැ. තව කෙනෙක් එතන ඉන්නේ නැහැ. So it's unique. Atomic number or the number of protons which have been inside the nucleus, that's unique to that specific element. Okay, just one element has the specific atomic number. And atom is, children, normally neutralized. Again, charge එකක් නැහැ. අපිට charge තියෙන ඒවා ගැනත් කතා කරන්න තියෙනවා. කියන්නේ සමහරට Na plus ion එක ගැන කතා කරන්න තියෙනවා. Cl minus ion එක ගැන කතා කරන්න තියෙනවා. But to this part you don't have to remember, but you have to learn about it, but not right now. Okay, I'm talking about the normal scenario. Normally an atom is electrically neutral. ඒ කියන්නේ charge එකක් නැහැ, zero. එහෙම වෙන්න, children, now protons are plus. එහෙනම් electrons protons ගානයි සමාන වෙන්න ඕනේ නේද? charge එකක් 0 වෙන්න. දැන් අපේ තන්න මෙතන +5 තියෙනවා. මෙතන -2 තියෙනවා. එතකොට charge එක කීයද? plus ඒවා තුනක් වැඩිනේ. මෙතන plus ඒවා බෝල 5යි. ලේසියෙන්ම ගමු. Then there are 2 minus balls. මේ බෝල දෙක අතන එකද ගන්නවට පස්සේ තව plus ඒවා තුනක් ඉතුරු වෙනවා. ඒ කියන්නේ එතන plus ගතිය වැඩි. plus charge එකක් තියෙන atom. So electrically neutralized වෙලා නැහැ. neutral නැහැ. plus charge එකයි වැඩි. එහෙනම් in order for an atom to be electrically neutral, the number of protons and the number of electrons should be equal. You all understand it? So for an atom to be electrically neutral, children, the number of protons and the number of electrons should be equal. Right now I told y'all atomic number denotes the number of protons present in the nucleus. So if the atomic number is 7, children, the number of protons is 7. That y'all know. I taught y'all that. And indirectly, it tells y'all, it gives you another detail as well. What is that detail? The number of electrons in that atom. Because for an atom to be electrically neutral, the number of protons should be equal to the number of electrons. So if you get an MCQ or else a question saying that the atomic number of this certain element is 7, find the number of electrons in it. So it's really easy. First you have to find the number of protons because those two have the direct relationship. Okay, so if the atomic number is 7, then you know, without hesitation, you can write down the fact that the number of protons present in that specific atom is 7. If the atomic number is 7, the number of protons is 7. And then you have to think, okay, fine. So this atom is electrically neutral, which means the number of protons should be equal to the number of electrons. And then you will understand, then it will be easy to y'all, you can write down the answer, the final answer. So if that's so, the number of electrons is also 7. Okay, so you can see it in this table. To take carbon, atomic number 6, proton 6, which means electrons should be also 6, because this atom is, you don't see any charge in it, plus minus both are same. Mass number, you denote it with the symbol A, children. Mass number the sum of protons plus neutrons in the nucleus. The nucleus subatomic particles protons and neutrons. Electrons, what it moves around the nucleus. What are the two subatomic particles inside the nucleus? Protons and neutrons. So the sum of protons and neutrons equals to the mass number. And it's been denoted by the symbol A. It is also really easy, children. Now imagine you get a question. The atomic number of the element is 7. Find out the and the mass number is 14. Okay, now the atomic number is 7 and the mass number is 14. Find out the number of neutrons. How are you going to find? Now if the atomic number is 7, then the number of protons should be 7 as well. Okay, so then we know that protons plus neutrons equals mass number. So protons 7, atomic number 7. The neutrons gana තමයි hoyanna ඕන. Mass number එක අපි දන්නවා 14 කියලා. එහෙනම් protons plus neutrons equals mass number නම් කොහොමද අපි කරන්නේ? අරක 14 නම් 7 අනිත් පැත්තට ගිහලා 14 minus 7 answer is 7. The number of neutrons is also 7. Do you all understand, children? So let's check this. The element fluorine. Now the question is, the mass number of fluorine is 19 and there are 10 neutrons. Find the number of atomic number. Then all of them neutron velai atomic number ke direct relationship එකක් නැහැ කියලා. So then how are you going to find? I'll repeat the question again. So the question says, this element has 10 neutrons and its mass number is 19. What is its atomic number? So how are you going to find this, children? You know that there is no direct relationship with atomic number, and neutrons. So then you have to go with the procedure. So if the mass number is 19 and the number of neutrons is 10, you know that the equation says number of protons plus number of neutrons equals mass number. So if the mass number is 19 and the number of neutrons is 10, then the number of protons should be 9. The number of protons should be 9. And now you know, children, number of protons is equal to the number of the number of protons is equal to the atomic number. So then what is the atomic number of fluorine? 9. It's really easy. And if they ask you another question, assume that this element is electrically neutral, then what is the number of electrons? It is also 9. So if the number of protons is 9, and if they have told us assume that assume that this element is electrically neutral, make a neutral කියලා හිතන්න charge එකක් නැහැ කියලා. So then what's the number of electrons? කියලා ප්‍රශ්නේ තිබ්බොත් it has to be equal to the number of protons. මොකද protons කියන්නේ positively charged එක, electrons කියන්නේ negatively charged එක. ඒ දෙක සමාන වෙනවා. The number of protons should be equal to the number of electrons for the atom to be electrically neutral. Okay? And there is a standard method of representing atomic number and mass number of an atom. This standard method is writing atomic number at the left side bottom end, mass number at the left side top end of the symbol of the atom. The information related to an atom of element sodium is given below. So we have taken sodium atom here. Sodium atom's atomic number is 11, children. Periodic table again, 11th box again, 11th atomic number is sodium to the end. So which means it has 11 protons as well. So if sodium is electrically neutral right now, it has 11 electrons as well. And if it's 11, the number of protons is 11. And the mass number is 23. Then how many neutrons are there? Mass number is number of protons and number of protons plus number of neutrons. Then if number of protons is 11 and the mass number is 23, the number of neutrons is 12. Okay? And this is Na. Normally Na is there as Na plus as well. Plus charge එකක් තියෙනවා normally. Cl minus again. අර ඒ වගේ ගොඩක් elements තියෙනවා, but normally අපි කරන්නේ electrically neutral විදියට. Okay, so now this is the standard way. You put the atomic number down at the bottom left hand side. Okay, left hand side bottom you put the atomic number, and which is Z. If they have asked you to just use the symbols and write, then Z දාන්නේ then Z atomic number use කරන්නේ. And the mass number, which is denoted by the symbol A, you put it at the left hand side top end. Okay, so this is the standard method of representing the atomic number and the mass number of an atom. Okay, children, so next week we'll be talking about compounds and mixtures. And then this lesson will be also over. So next week we'll be learning about, I'll be teaching y'all compounds, and it's not hard, and mixtures. Okay, so like I always tell y'all, y'all can ask me any question you want to, and I will be really happy to answer y'all. I always tell you that. So good luck with your studies. Stay safe and take well care of you. So see you next week. Bye.